Yeah, hello, good evening everyone. So welcome to week 12 discussion class for course Design of Photovoltaic Systems. And this course is being taken by Professor L. Umanan from Department of Electronic System Engineering, ISC Bangalore. And I am Ravi Kumar, a PMRF research scholar at IIT Bombay. So up till now, we have seen basics to the PV, that is the photovoltaics, then integration of photovoltaics with pumped hydro, then Peltier system, and also with grid. So these were the, so first part we have covered the basics. In the second part we have covered the application part. So in this third part we are going to cover the economics part. Economical part of the solar photovoltaic system. So in this particular thing, we will see what is this life cycle cost, what is this annual life cycle cost, what is the cost of unit production. So these are the basic concepts which we are going to cover in today's lecture. So let's start with this life cycle cost. So for this life costing, we have different growth model. So it's all about like something is increasing. Let's take an example. You are like putting your money in bank. Why you are putting your money in bank? Because bank gives some interest. So it means your money in bank is growing. But at what rate, at which model? So it depends on which model they use. So they simply use the simple interest model. So they have like fixed interest on your principal amount yearly. So based on these things, we have different models. So first we have linear growth model, that is a simple interest. Then we have compound growth model. So compound growth means, let's say we have some amount A, and in the first year we have got some interest I. Let's AI, A naught. So at the end of first year, it is the amount. At the end of second year, A naught plus 2 AI, it is the amount. So it is based on simple growth model, or we can say linear growth. But here the increase, this AI is increasing based on this A naught only. But in case of a compound growth, in the next year, this complete A naught plus AI will become our principal amount. So it will be like A naught plus AI. Then this I growth will be applicable on this particular thing. We will understand this in the further slides. So this is the second model. And if this is having like this growth is being captured for the nth year, or we can say like monthly, yearly, biannually. And if this n, or we can say the time is squeezing, time is delta x is going to 0, then this become an exponential growth model. So these are the three famous models which are used for this life cycle costing. We will understand each of them one by one. So first let's see what is this linear growth model. So it is just a simple interest model. So I is the rate of interest for an interval of time delta t. So here delta t we can assume 1 year. And n is the number of year or number of time interval on which this delta t is under consideration. So number of years under consideration. So it is the rate per year and it is the number of years. And we have some amount S naught initially. After 1 year it becomes S1, then S2, S3, S4. So after nth year it will become Sn. So Sn, yes. So this S1 is S naught into I because I is the interest rate. So this is the at the end of first year. And if this is at the end of second year, so at the end of nth year, this will be the total amount. So this is just a simple interest, or we can say linear growth model. Now we will see the compound growth model. So in this compound growth model, what we do, we have same thing. I is the rate of interest for delta t interval, and n is the number of intervals delta t is being considered. So this is the same thing. One interval, 2, 3, 4, and n, and this is the amount before, like initially, and then S1 after first interval, second interval, third interval. So in this compound growth model, this S1 will be the same. It will be the S naught plus S naught into I. For the S2, now S naught will not be considered here because now S1 will be considered as an initial model. So for this particular S1, this is the initial. For this S2, the amount which is at the end of first year, it will be as the principal amount. So this way we have this particular equation, and using this equation, this is the particular formula we get for this compound growth model. So it is just the compound interest model, same thing. Now third, we have exponential growth model. So in this particular exponential growth model, what we do, we divide intervals in another intervals. So let's say first 1 year is divided into m different intervals. So delta t time will be the 1 by m, and interest also being divided, then it will become I by m. Same thing, this particular year we have divided into m small intervals, and then if we apply the compound growth model, so we get this particular thing Sn, same thing which we have seen in the previous slide. And let's say this x is I by m and m is equal to I by x, then so this simple interest model here, just thing is that if m become infinite, so we are just saying that this intervaling which we are doing between two intervals, if it become infinite, it means we are making this from discrete to the continuous thing. So because it is n or infinite number of divisions between this S naught then Si, so then it become an exponential growth model. So this is the particular equation which is used for exponential growth modeling. Now we will see an example, and we will see what is the impact of simple growth, compound growth, and exponential growth on any amount, and which is the fastest growth model and which is the least growth model. So this is the example. So we have considered I, that is the interest rate, that is the 5% per year, and we have considered n equals to 5 years, and S naught we have taken 1. So this 1 after 5 years become 1.25 in simple interest model, simple growth model. In compounding it become 1.276, and in exponential it become 1.284. Similarly, after 10 years it become 1.5, it become 1.628, and it become 1.648. After 15 years, 1.75, 2.08, 2.12. After 20 years, it become 2, it become 2.65, it become 2.72. And after 25 years, it become 2.25, it become 3.38, it become 3.49. So we have seen this is the fastest growth model. and this is the least growth model. So the amount we can say is growing faster in exponential growth model, and it is not growing much faster rate, or it is the least growth model, that is the simple interest model. So this is, you need to know these formulas to calculate the amount after any interval. So this is the things you need to remember. Now let's move to the next thing. Why we are doing this? See, let us consider we have a power plant which we have like installed today. Let's say we have a solar PV on our terrace. We have taken the module, we have taken everything, inverter and all. We are putting cost today. And what we are saving? We are saving on our electricity bill. And that saving is monthly. That is not today. So what we need to do it, the entire cost which we are putting today, and also the maintenance cost which we will be putting after 1 year, 2 year, 3 year. So is there any formula by how we can get this entire cost divided into yearly? It means, can we get our total investment spread over 25 years yearly? So this is the formula which we use. So that is the LCC, ALCC, and for calculating LCC and ALCC, we need to know some formula which talk about the present worth. It means, let's say we have 100 rupees today, and we will be having same 100 rupees after 1 year. So this the rupees which we are getting after 1 year, what is the present worth of that rupees today? So that is the question. So there are two things which works. Let's say you are buying something. Let's say you are buying a TV and you are having some amount and you are putting it into bank. So the amount will increase with some interest. But there are another thing as well. There is inflation. So due to this inflation, we can say the cost of this TV will also increase. So by considering this inflation as well as this interest rate, can we calculate the present worth of an item which we are going to purchase after 1 year? So this is the basic idea why we are studying these kind of things. So first, for this we need to understand what is the present worth of anything which we need to consider after some time. So let's say we have some amount S note, that is the money. We have some item, that is the costing C note today. So that is the cost today, that is the amount today. So with the interest rate I, our amount will increase. And with the inflation, the cost of item will also increase. So to purchase this item, this increase in interest rate and this increase in the cost of this item should be equal at any point of time. And if we do this, we can calculate how much amount we need to save today to purchase an item which is costing this much today. And after an year, like after 5 years, after 1 year, or after 10 years. So this is the particular formula. By using this, we can calculate the amount which we require today. Let's say you want to buy a car that is costing, let's say 10 lakh today. That is costing 10 lakh today, but you don't have 10 lakh today. What you want to do? You are thinking after 5 years I will purchase this car. But the cost of or we can say the cost of this car is increasing with the inflation. We can say, let's say inflation F is, let's say 5%, and your interest rate which you get in bank, let's say it is 4%. So to purchase this car, that is 10 lakh today, how much amount you need today? How much amount you need to save today? How much amount you need to put in your bank today? So let's calculate this. So this is the S note we are calculating. It is 10 lakh. After 5 years we are talking about. So 1 plus 0.05 divided by 1 plus 0.04 into 5. I'm doing calculation. Because here inflation is more as compared to our interest rate, so we need at least 10.5 lakh today in bank, in our account, and it will become 10 lakh after 5 years, because the interest rate is less but inflation is more. So this is the way how you can calculate the present worth of anything after 5 year, 10 year or nth year. Okay, let's move further. There is a basic thing, like this was a like sale on Flipkart and Amazon and all, and you must have purchased something and you must be aware about this EMI thing. So what is this EMI? It is the equivalent monthly installments. So how they calculate this monthly installments equally? So if this can be yearly, this can be monthly. So now we will see a formula using which you can calculate your EMI with your own self. So let's say this is the nth year, and after each year you are doing a payment of D, and you are doing it for nth year. So this Sn equals to, what is this? This is the amount. S naught is today. This is the amount which will be after nth year, that is the compound growth. Compound growth. And if you rearrange this, we can calculate S naught, that is the today value, present worth. So using this we can have this kind of factors, that is the present worth factor or future worth factor. Okay, we are calculating something else. So if we do this using this formula, we put it here because we are doing equally. So 1 year, 2 year, 3 year, 4 year, after we can get particularly this formula finally. So this particular thing tell us the present worth of all your future annual installments taken together. So this is the amount value today which you are going to pay after nth year while you are paying D amount annually. So this is the total amount, the value of this total amount today, in today, not after 5 years, not after 2 years. It is the present worth. So because we are doing this using this formula, so this particular factor is known as present worth factor, and this will be used in questions to calculate many things. Many things, let's say you have maintenance. In your solar system, you are doing maintenance after every year. So you are putting 1000 rupees every year in your solar system. In 25 years, how much it will cost according to today? You can calculate that using this formula. We will be doing when we will solve few questions. Okay, so here in this particular case, we have not considered inflation. We have considered inflation is 0. And if we consider inflation, so considering inflation, we will have this particular F factor as well. In the previous thing it was 0, and if we do the same thing while calculating this inflation, we get this particular formula. And this is the same thing, present worth factor, by considering the inflation. Okay, so now we have seen how can we calculate the value of anything which we are going to put in future in today's terms. So that was the all things. Now let's come to the LCC, that is the life cycle cost. If you are having a solar system, or if you are having a PV system at your home, then what all cost you will put in your system? You can write in the chat box. I'm like watching your chat box as well. Whatever comes to your mind, whatever you will spend on this solar PV system. Initially you will purchase solar PV module, then you will purchase all the system, then you will do maintenance, okay. So there are components of this LCC. We will do like seeing what are those components. So first we have capital cost. Whatever we are purchasing today in terms of capital, in terms of system, like number of PV modules, inverter and everything, that is the capital cost. Then replacement cost. Let's say our PV module will run for 25 years, but we have a solar pump, water pump system, and our pump will work only 5 years. Then in 25 years, we need to replace our pump 5 times. So we will consider this replacement cost as well. Then we have this maintenance cost. The solar PV system or like entire system will require some maintenance. It may be annually, it may be after 6 months, it may be after 5 years. So we will consider this maintenance. Then we have energy cost, if we are putting some energy. Then we have some scrap cost. Let's say after 25 years, your system life is complete. Now what will you do? You will sell the entire system in scrap. So we will also have this scrap thing as well. Then LCC is calculated by adding this capital cost, replacement cost, maintenance cost, energy cost, and by subtracting this scrap cost, because by selling your scrap you are not putting money but you are getting money back. That's why we are subtracting it. So this is the way how using this you can calculate this life cycle cost of anything. Okay, now let's come to the questions. So first question says the cost of solar heater is 25,000 rupees. Inflation rate is 6%, interest rate is 10%. What is the present worth factor for n equals to 3 year? Following the compound interest model, and assume installments are annually. These are the options. SVP. No more, we are not discussing that. We can discuss it tomorrow if you want. So this is the question. It says the solar heater is 25,000 rupees. Inflation rate is 6%. Interest rate is 10%. What is the worth factor for n equals to 3? Present worth factor. If you require any formula, let me know. Solve it. I am giving you 2 to 4 minutes. Do you require any formula for this? We require a formula which should have this inflation rate and interest rate both. Okay, I am giving you the formula. So this is the formula which we will be utilizing. So we just require this particular thing. The question is asking about this present worth factor. What are the factors given here? We have given initial cost, that is rupees 25,000. Then we have given inflation cost, that is 6%. Then we have given interest rate, that is 10%. Then we have given n, that is 3 years. Just put these values in this particular formula and let me know the present worth factor value. Are you doing this? Just put the values. Okay, what is F? So it will become 1 plus 0.06, 0.10 minus 0.06, 1 minus 1 plus 0.06, 1 plus 0.10 to the power 3. That's it. Let me solve this. what if I, yes, what if I is less than f such that it becomes negative? What become negative? Okay, we will do that as well. We will like replace this I and f. First we will solve this, then we will see. And it will become negative, so there is no issue in becoming negative as well. Then your money will decrease. So like if one is increasing, let's say we have 100 rupees today, and after a month, let's say 2% is inflation rate and 4% is interest rate, that is monthly. So effectively our money will be 2% more. So our money will be 108, 102. But let's say it is reverse. The inflation rate is 4% and interest rate is 2%. Then our money will be 2% negative. So our money will decrease because inflation is more in that case. So negative signs that our money will decrease. I am getting something 2.78. What is next? 7. So it is corresponding to 2.79. And this 2.79 is C. Yes, Ramya, right. 2.78, 2.79 is the correct answer. Okay, so we are moving to the next question, which says in question 1, if the inflation rate and interest rate are same, what is the present worth factor following the same compound interest model? And these are the options. It is saying if both are same. If both are same, then what will happen? See, before while we were solving this particular thing, yes. So we have solved this by taking the by taking these conditions. I is not equals to f, I equals to f. So we already get this become n equals to m, n mathematically. So it is equals to n if I equals to f. So same thing this question is asking. It is asking what is this present worth factor if I equals to f, and if I equals to f, then it become n. And n is, what is n? N is given as 3. So it is B. So correct answer here is B. Let's come to the next question based on this question only. So the capital cost of, okay, not this question, different question. It is based on the PV system. So the capital cost of a PV array is 2 lakh rupees and the life of PV array is 25 years. The annual maintenance cost is 1000 rupees per year. Consider a scrap cost of 10,000 at the end of its life and an interest rate of 10% on the maintenance charges. Ignore the energy cost, calculate the maintenance cost. So you need to calculate total maintenance cost which you will be putting in future annually. What is the total cost of those maintenance in present value? And these are the options. Very simple question. First of all, let's see what other things are given here. Write the factors which are given here. So we have given capital cost as 2 lakh. We have given lifetime is given 25 years. Annual maintenance cost is given rupees 1000 per year. Scrap cost is given rupees 10,000. Interest rate is given 10%. Inflation we will consider 0 because not given. Energy cost we need to ignore. So it is like this is the cycle 1, 2, 3, 4, 25. So we are putting 1000 rupees here, 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 here. So every year we are putting 1000 rupees. But there is an interest rate as well. So what is the total cost? So you need to calculate the same formula which I told you while describing the installments. If you are putting something in future, how you can get the value of those future installment today? So this is the particular formula which I am talking about. So this is the total maintenance cost in our term. This is the maintenance cost annually we are giving, and this is the present worth factor. For how much year we are doing so. So in this particular question, they asked us to calculate the maintenance cost. So total maintenance cost will become 1000 into 1 upon 10%, 0.1, 1 minus 1 upon 1 plus 0.1 to the power 25. Just solve it and let me know. If we do so, how much we are getting? No, percent worth C. This particular formula says if we are doing D, we are putting D amount annually for n year with this I interest rate, then what is the value of this total amount in today's terms? So now comes to the question. We are putting 1000 rupees every year with the interest rate of 10% for 25 years. So then this percent worth is calculated for 25 years, and it have considered that we are doing it annually. That's why this is the formula for this maintenance, overall charges of maintenance in present value. So if you have confusion, you can look here. See, in this particular thing, I told you that this is the I'm not getting my screen. Hello. Okay, there was some issue with the internet, I think. See, I was talking about this. So we are putting D amount. So let's say we are putting maintenance cost annually, and and that is with the interest rate I compounding. So if we do this all summation and do the mathematics, we get particular this formula. That's why we are using this formula. So this percent worth factor already have taken or have considered that we are doing it year by year. But let's say we have something to put after 10 years and we want to get the percent worth of debt only one times. So for that particular case, we have this formula only. This is the simplest formula. So this formula is not considering that we are doing it year by year, but this formula is considering that we are doing this year by year. That is the difference here. Yes. So someone said 9077. Yes, that is the correct answer. So total maintenance cost will be 9077 in terms of today. So can you see this? We are putting 1000 rupees every year for 25 years. And if we calculate flat, so it is 25,000 rupees. If we do just in the lay term, if we just calculate that we are putting 1000 rupees every year, so how much rupees we require? We will say 25,000. But no, actually the value of money will increase with the interest rates. That's why in place of 25,000 we require only 9,000. So that's the difference. Rather than 25,000, we require only 9,000. Okay, so based on this particular question only, same thing, it's everything is same. PV array value 2 lakh, time is 25,000, maintenance cost is same, scrap cost is same, interest rate 10%. Now we need to calculate the LCC. life cycle cost of the PVL, and these are the options. First, consider what all components we require in LCC, then just add or subtract them. You will get the value. See, for LCC, you require to add capital cost, and this is the replacement cost if any, maintenance cost, energy cost minus scrap cost. We don't have energy cost, 0. We don't have replacement cost, 0. We have maintenance, we have this capital, we have this scrap. Scrap cost is given already. Maintenance cost we have calculated in previous question, and this care capital cost is already given. Just add and subtract. Capital cost K is 2 lakh because we are putting today, so it will be 2 lakh only. And maintenance cost, how much we calculated? 9077. Yes, 9077. We have calculated this 9077. Scrap cost is 10,000. So total LCC will be 2 lakh plus 9077 minus 10,000. How much you are getting? Yes. Yes. We are getting 199077. Okay. Let me say, let me just have some change in this question. So we are considering this scrap cost in terms of today, 10,000. Let's say this 10,000 in terms of today, and in second part, let's say this 10,000 is after 25 years. Now what will be the LCC? This 10,000 is today, but if it is not in today's term, it is after the 25 years. Now what will be the LCC? So in this particular thing, first you need to calculate the present value of those 10,000 rupees. And how you can do that? How can you do that? Simple formula. Present worth will be equals to future worth. I'm putting like with future worth 1 plus f divided by 1 plus I to the power n. Then how much we are getting? This P note. So in place of 10,000, you will put this P note, and how much P note you are getting? F is 0. So it is like that. So it is like that. 1 plus, 1.1 to the 1 divided by 1.1 to the power 25 into 10,000. So it is just 922 rupees today. So this 922 rupees will become 10,000 after 25 years with 10% of interest rate. So in place of this 10,000, we will put 922 only. And then this LCC will equals to plus 9077 minus 9. So our LCC will be 208155. Okay. So answer here is 199077. That is the option A. That is the correct answer. Let's move to the next question, which says same question, capital cost 2 lakh, array year lifetime is 25 years, annual maintenance cost is 1000 rupees per year, scrap cost is 10,000, interest rate is 10%, ignore the energy cost, calculate the present worth factor. So here now you need to calculate the present worth factor, and these are the options. What all things we require in present worth factor? Okay, this is the formula, and this is the present worth factor without F. Now I think you can calculate easily. How much you are getting? So our present worth factor will equals to 1 by I into 1 minus 1 upon 1 plus I to the power N, and I is given 10%, N is given 3. Oh, sorry, N is given 25. So we will put it like this: 1 upon 0.1, 1 minus 1 plus 1.0, 1.1 to the power 25. And if we do the calculation, 1 divided by 1 to the power 25, 1 minus 25. How much we are getting? We are getting 9.077. That is the present worth factor here, and answer is B. Let's move to the next question. Simplest question, do not require any formula, just think about it. If farmer borrows money from a landlord for the irrigation system, which of the growth model will prove to be most expensive for the farmer? And these are the options: A, B, C, or D. Exponential. Yes, exponential is the correct answer. Here the same for example which I have given you. These values are lower than these values after any year. So this exponential growth model will be more expensive. So answer here is D. Let's move to the next question. In an E core, so as shown here, there is a winding as shown in the figure. Each winding is connected to a source. So it is connected with the source here, it is connected with the source here. Which of the following is correct regarding the source? Number of turns of each winding is equal. And these are the options. If you have gone through the lectures, you can answer this easily. Can be voltage source, can be like current source, or which require one voltage, one current source. Okay, Rajnikant have given already the answer. Yes, we require to control voltage and current, so one current and one voltage. So here two can be voltage source, one can be current source. Correct answer. Next question. In the magnetic circuit given in the figure, initially this S switch was kept open. So there were, we can say, some mutual inductance or some kind of current withdrawing here. When the switch is closed, then the current through the source V, this V, will be zero, remain unchanged, decrease or increase. T. Yes, it will increase. So these were the simplest question. Now we have a tougher question, but you need to solve it. Simple one, need your whole calculation part here. So we have here like 20 families. Let us suppose each family has 5 members. So we are talking about a village, 20 families, each is having 5 members. The source of water to the village is from borewell supplied using hand pumps. So it means the source of water to the village is through the hand pumps only. The density of water is given 1028 liter per meter cube due to various salt or heavy metals and is independent of temperature variations. There were 6 hand pumps which are installed to meet the requirement of per capita consumptions of 40 liter per day. The borewell depth is 20 meters. The cost of each hand pump is 5,000 rupees. The cost of digging each borewell at the rate of 250 rupees per meter. The lifespan of the hand pump is 10 years. Life is given 10 years. The annual maintenance cost is 1,250 rupees per hand pump. And if the interest rate is 10%, then what is the unit cost per meter cube of water for a life cycle of 20 years? So you need to calculate the unit cost per meter cube of water if we are withdrawing this water for the 20 years. And these are the options. Okay, Mohan saying how. So Mohan, it is like if you have got to the lecture, you have seen that if the switch in between is open, so there is a roll of that coil. If it is closed, then there is no roll of that coil. So first of all, in this question, you need to write each and everything neatly so that you can get what is given and what you require in each calculation. And there will be two terms in the sense you will be doing this like this. First LCC calculation and second will be the total water required. Because then only you can divide this LCC, or we can say ALCC, that is the annually, and you can divide it with the total annual water which you will withdraw. A ALCC. So try this, let me know whenever you require any help. So we will be requiring more space. So let me add a slide here. Okay, first we will write each and everything which are given. So let's calculate this total water requirement first. How many families? Member in each family? Per family 5. Total people equals to 100. So this we have taken considered. Let us suppose this family 5 members considered. The source of water to the village borehole, density, heavy, independent terms, the 6 hand pumps which are installed to meet the requirement of 40 liter is the requirement. So per day water requirement. So per day water requirement will be 100 people into 40 liter per day. So it is 4,000 liter per day. And in a year, it will be 365 into 4,000 liter per year. So it will be how much if you calculate this? It is 65. It is 1460000 liter per year. And in meter cube, because question is asking unit cost per meter cube. In meter cube, it is 1460000 divided by 1028. It is the density given. So you will get divided by 1028. 1420.23 meter cube per year. So this is the water requirement of per year thing. Now we need to calculate LCC or ALCC. For this I need to calculate, add the page 1. Okay. Wait a minute. Yes. So what we have got? 1420 water requirement. So water requirement one four two zero point 23 meter cube per year. Now we will calculate this ALCC or LCC. First we will calculate the LCC. what all the things we have given for this? We have given number of hand pumps. How much are number of hand pumps? 6. Then we have given bore well depth. That is 20 meter. Then we have given cost of hand pump. It is given rupees 5,000. Then we have given cost of digging. It is given 250 rupees per meter. And hand pump lifespan is given 10 years. And also AMC, that is the annual maintenance cost, is given 1250 per hand pump. And this interest rate is given 10%. So first of all, what we require, we will do capital cost. Capital cost. So capital cost is like cost of hand pump, that is 5,000 into 6. It is the cost of hand pump, plus cost of digging. It is 250 into, we have 20 meter borewell depth, into for 6 different hand pumps. So total capital cost we have 60,000 rupees. Now we have replacement cost. So it is for 10 year, lifespan is 10 years given, and we have to do this entire thing for 20 years. So it means there will be one replacement after 10 years. So it's like 20 years, 0, 20 and 10. So here we will have a replacement cost. And in between we will have a maintenance cost, AMC. So every year we will have maintenance cost, and initially we have a capital cost. So capital cost we have calculated. Now we are calculating this replacement cost. So we have replacement cost of 5,000 into 6, but that is after 10 years. So what is the present worth? That will be 1 plus 0.1 into 10, because after the 10 years. So here we are not considering that every year we are putting something. So we are having a lump sum after 10 years. So what is the present worth of that lump sum in today's terms? So if we do so, how much we are getting? It is like 30,000 into 1 upon 1.1 into 10. So what is the value we are getting? Let's solve this. One divided by 1.1 to the power 10 into 30. So I am getting rupees 11,566.29. So this is the amount which I am getting in today's terms. So first cost is this 60,000. Second cost is this is the maintenance cost. What is left? Left is the maintenance cost. So maintenance cost will be our AMC for 6 different hand pumps into present worth factor. So here we are doing it annually. So our present worth factor will be like this: 1 upon 0.1 into 1 minus 1 upon 1.1 to the power 20. And if you do so, our AMC is 1250 into 6, 1 upon 0.1, 1 minus 1 upon 0.1 to the power 20. I am writing here only. And if you calculate how much you are getting, 1250 into 6, and this factor we get 8.514. And total we get 1250 into 6 into 8.514. It is coming around rupees 63,855. So this is the total maintenance cost. Yes. Now our LCC will be K plus R plus M, because we don't have any energy cost, we don't have any another cost, so just need to add these things. So our LCC will be coming $60,000 plus 11,566.29 plus 63,855. So I am getting rupees 1,35,421.29. And this is LCC, means overall cost. Now let us divide it into yearly. So our ALCC will be, so using this particular formula only, we will divide it with these things. So if this goes to here, so we can get the yearly division. So our ALCC will be LCC divided by present worth factor. So it is like rupees 135,421.29 divided by 8.514. And how much we are getting this? Divided by 8.514. I am getting rupees 15,905.70. So this is the amount which we are spending annually, and with this amount, this is the water which we are getting yearly. We have calculated ALCC because here we are calculating this yearly. Now what we will do, we will have unit cost of water. it as ALCC divided by amount of water per year. So it is like rupees 15,905.72 divided by 1420.23. It is like meter cube and it is like rupees. So our answer will be coming divided by 1420.23. I am getting 11.19 rupees per meter cube. So this is the cost of water which we are getting. And what was the options? Yes, 11.19 means 11.2. So correct answer here is 11.2. So this is how you can calculate or you can solve any questions. So this is all about today. We will be having a special class tomorrow, and in that class the agenda which I am thinking, we will do the calculation from scratch, and for our homes, actual homes, we will plan a solar PV system for our home. So before that, if you can do it, you can just write each and everything, what appliance you have and what is the approximate timing you use them. Let's say fan. So how much, for how much time daily you use how much fan, or like what is the wattage of that fan, how much light you have, what is the duration of TV you watch, what is the duration and time when you use your washing machine, what is the time or what is the wattage of your refrigerator, and how long it runs entire day, like 6 hours per day or 20 hours per day. Yes, Mohan, you may provide information regarding metal frame section for mounting panel that can withstand. Mohan, I will try to find out this information as well, because I am not expert regarding this metal frame and all, but I will try to cover some if I get something on this. I will try for this as well. So like in after that class, you will see how much load requirement, how much battery. Yes, I will try. I will try to do that. 120 kilometer per hour speed. Okay, I will do that. So after that, you will be able to find out what is the battery requirement you have. I mean that actual system planning will be done, and really you can install that system at your home. And even like government is providing subsidy and all, if you wish to, you can get that. So that's all about today. We will meet tomorrow, and officially we can say this is the final class for this lecture, but that is an extra lecture which will be like I am taking tomorrow, and that will be the last class. It will be the same from 6 to 8. Saturdays tomorrow from 6 to 8 p.m. Link will be same link you can join. Even you must have received an email regarding this, like same link is provided, and from that discussion forum you can get the link as well. Same link will be utilized. Yes. Okay, thank you everyone. Have a nice day. So tomorrow we will also have Dussehra, so let's celebrate, and happy Dussehra in advance. Take care.